Transformation rules can help us graph our parent functions with ease. Therefore, let's consider the parent function f of x equals x cubed. So we learned several of these in a previous video. Let's just use x cubed for an example. If I have a function and I am going to add a constant on the outside of that function, it is going to result in a shift up c units. So for instance, if my parent function that I'm talking about is x cubed, then if I add c units on the outside of that function, it would look like x cubed plus c. If I subtract a constant, it would look like x cubed minus c, and that will result in the parent function shifting down c units. If I want to shift a function left, I'm going to add a constant inside the function. So I want to start using some better notation here. F of x plus c might look like that. F of x minus c would look like this. And then let's try f of x plus c. That would be x plus c cubed. So that would be left c units. And if I want to move it to the right, I'm going to subtract c. You're probably thinking, I think she made a mistake. I did not. It is the opposite sign when it's inside the function. So that would be x minus c cubed. That would go right c units. And then an opposite on the outside, the opposite of f of x would be the opposite of x cubed. Let me fix that. The opposite of x cubed. And then an opposite on the inside is a reflect over the y-axis, and that would be the opposite of x cubed. So this acts as a reflect over x, and this is a reflect over y. So your negative inside is a reflect over y, your negative outside is a reflect over the x-axis. Now we can also have stretches. So we can have horizontal stretches and shrinks. So if I multiply my function by a value on the inside of the function, so for instance, if I took, instead of just x cubed, let's say I had, actually let's do something that you could see just a little bit better. Let's change to f of x equals the square root of x. This way you could see the difference between inside and outside a little bit easier. So if I have a horizontal stretch or shrink happening, a stretch is when I'm going to have a value on the inside that is greater than 1. Now this value right here, this coefficient, we're just looking at the positive value. So if that positive value is greater than 1, then we have a horizontal stretch. And if we have one that is less than 1, maybe 1/3, then we're going to have a horizontal shrink. And then if we multiply on the outside, so if I take that 2 and I put it on the outside, I'm going to end up with a vertical stretch. And if I take a fraction that's less than 1 on the outside, we have a vertical shrink. So I'm going to show you some examples, not with parent functions, but an example with just some kind of a graph, and I'll show you how that graph is transformed in the next video.